Today we're going to learn about similar triangles in Lesson 20-1, Exploring Similarity. Our learning targets are: I will identify similar triangles, and I will identify corresponding sides and angles in similar triangles. So when you walk out the door today, I want you to be able to tell me about identifying similar triangles. Can you identify similar triangles? Our action verb here is to identify, and what are we identifying? Similar triangles. We also need to identify, our action verb once again is identify, and we're identifying corresponding sides, angles in similar triangles. This lesson will not last 2 class periods because I'm going to take out numbers 1 through 6 because it's more of an activity, and we are just going to do number 7, check your understanding, and the lesson practice. We will also have more practice in class. This activity is a guided activity. Let's begin. Similar polygons are polygons in which lengths of corresponding sides are in proportion, and the corresponding angles are congruent. There are some vocabulary words here that we should know about. We should know what a similar polygon is. We should know what a polygon is. We should know what corresponding sides are. We should know what proportion is. And we should also know what the word congruent is. Now, these words are already in your vocabulary list, so please take a look at your vocabulary list. But we are going to key in on 2 of these. It says, similar polygons in your notebook are polygons in which the length of the corresponding sides are in proportion and the corresponding angles are congruent. Well, let's think about that. If I look at this figure here below, we can see that the corresponding angles are congruent. We have 96 and 96 degrees, we have 25 degrees and 25 degrees, and then we have 59 and 59 degrees. So, because the angles are congruent, then these 2 triangles are similar triangles, okay? And you can have similar shapes. In this case, we are talking about similar triangles. Now, it says here in our side notes, when 2 ratios are equivalent, then they form a proportion. For example, the ratios 3/7 and 12/28 are equivalent. Setting these ratios equivalent generates the proportion. Therefore, these 2 triangles, being that their angles are congruent, then their side lengths are also congruent. So let's take a look at the corresponding sides of both of these shapes. Here we have 18 and 12. Notice how I'm matching the longest side with the longest side. Here we have 9 inches and 6 inches. Notice how I'm matching the shortest side with the shortest side. And then we have here 21 and 14. Notice how we're matching those, and both of those are at a slant. So let's go ahead and set up a proportion. So if we're doing, I always try to go small, large. You can also go both ways, and I'm going to show you both ways. In setting up a proportion for these triangles, let's take a look at 12/18 is equal to, let's go with 6/9. And then let's go with 14/21. So when we take a look at all of these, can they be reduced? How much can we reduce 12/18 as a fraction? 12/18, if I decide to do 3 goes into 12 4 times, and 3 goes into 18 6 times. Well, it can still go lower than that. Let's try 6. 6 can go into 12 2 times, and 6 can go into 18 3 times. So this reduces to 2/3. Let's look at the second one. This can also be reduced as 3 goes into 6 2 times, and 3 goes into 9 3 times. On this next one, 7 can go into 14 2 times, and 7 can go into 21 3 times. So when we reduce these, you can see that we have a set of ratios that equally generates a proportion. A set of ratios that equally generates a proportion. And because they're equal, because the proportion of each of the corresponding sides are equal, then these two triangles are similar. Another way that you could have done this is you could have flipped it over. I like to do small on top. Some of you might have said, well, let's just do 18 over 12 is equal to 9 over 6 or 21 over 14. And then this would have reduced to 3 over 2, 3 over 2, and 3 over 2. It does not matter. Because it does not matter, they're all equal. It does not matter. It doesn't matter if your larger triangle is on top and your smaller triangle is on the bottom. As long as your ratios are the same, then that means that the triangles are similar. Now, if the ratios were not the same, and let's say in this first one, we would have gotten a 4 right here instead of a 2, then these two triangles are not similar. But because the ratios are the same, once again, I'm saying it once again, the ratios of the corresponding sides are the same, then they are congruent. Last, I want to say this. Instead of reducing them to fractions, you could have also done division. If I would have done division here, 2/3 as a fraction is 0.67. So I would have had 0.67 is equal to 0.67 is equal to 0.67. And then over here on this one, I would have had 1.5 is equal to 1.5 is equal to 1.5. Doesn't matter how you do the ratio, as long as you can identify the fact that they are all the same. Let's move on. A similarity statement for triangles below is triangle PWM is similar to triangle EFM. A similarity statement indicates that the corresponding angles are congruent and the corresponding sides are proportional. So if these two are similar, then we can write a similarity statement. I want to point some things out about this similarity statement. Let me rewrite it down here. It says triangle PWM is similar to triangle EFM. I want you to take a look at these first letters, P and E. If you notice, P corresponds with angle E. P corresponds with angle E. Let's take a look at the other letter. We have here W and F. If you look at W and F, they also are corresponding angles. Notice that this is the right angle of the triangle. This is the right angle of the triangle. And then also they share point M. So whenever you're writing similarity statements, the angles have to correspond with each other in according to how you write it. If I start with P here, then the side or the angle that corresponds with P, which in this case is E, you have to start with E here. If W is your next angle, then you have to use F because it corresponds with F in the next portion of the similarity statement. And then if M is in this position, then you also have to put M in this position. Okay? Notice that in naming triangles, you have the triangle sign, and then you have capital letters that are in what? Alphabetical order. Okay? Alphabetical order. Well, I take that back. Not alphabetical order. they are in order according to their angles. They are in order according to their corresponding angles. Before, when we were naming triangles, usually when we name triangles, for example, triangle A, B, C, we usually name them in alphabetical order. But in this case, for similar triangles, as long as your corresponding angles are in the same position from here to here, then you are good. All right, let's move on. The diagram below shows two similar triangles like the triangles you worked in item 3. Now, we didn't work a triangle in item 3, but that doesn't mean that we can't do this. Use the length of 3 pairs of corresponding sides to create 3 ratios in the form of side length in small triangle over corresponding length in large triangle. Notice that they always do small and they always do large on the bottom. Compare these ratios in part A, then explain how these ratios relate to the ratios created in item 3. We're not going to do the portion with item 3. I just want you to tell me, how are these two triangles similar? But before we continue, I want you to also know that these are two separate triangles. It's just that they share a common vertice right here. But these are indeed two separate triangles that share a common vertice. Okay, so how do we prove that these are similar? Well, we look at the picture. There are no angles given. Now we know that these are right triangles here, but we need two or more, excuse me, we need two or more angles in order to prove that these are congruent. And we don't have that here. We only have one angle and we need two or more. And we learned this last year in geometry. Now, let's take a look at the corresponding sides. So if I go from the small triangle and I use, let's get a different color, 3, what side corresponds with 3? Well, that would be 12. So if we did 3 over 12 is equal to, let's go with 4 next. 4 corresponds with 16. So 4 over 16 is equal to, and then we have 5 and 20 left. 5 over 20. So let's go ahead and see if we can reduce these down. Obviously, on the first one, 3 over 12 is 1 over 4. 4 over 16 is 1 over 4. And 5 out of 20 is 1 over 4. So the sides are proportional. The corresponding sides are proportional. Therefore, these triangles are similar. Okay? And if they were labeled with letters, we could write a similarity statement. Okay? Let's move on. Let's take a look at check your understanding. Are the triangles shown below similar? If so, explain why and write a similarity statement. If not, explain why or why not. So I want you to pause the video and complete the check your understanding and then come on back and verify your answers. Remember, I need you to struggle through this. Don't just skip ahead in the video. Try to struggle through it. That way you learn by doing. So pause the video at this time. So let's see if the triangles are similar. Let's go ahead and line up the sides. So in a triangle, we have here side 5 centimeters is going to match up with 10 centimeters. And then we have $12 centimeters is going to match up with 24 centimeters. And then we have 13 centimeters is going to match up with 26 centimeters. So let's take a look at that. So the first thing I'm going to do is try to see if the sides are proportional, the ratios of the corresponding sides